Welcome to Aviation World.
Welcome's A320 series fuel lesson. The A319 fuel system is significantly different than the A321 fuel system. The A321 fuel system is covered in the differences section. We will start with an overview of the system. The A319 fuel system provides fuel storage in center, inner, and outer wing tanks, supplies fuel in the correct quantities to the fuel tanks during refueling, supplies fuel to the engines and the APU, circulates fuel to cool the IDG oil, and supplies information to the ECAM. As we progress through the lesson, you will learn about the overhead fuel panel, the fuel page, and the fueling panel. Before we move on to controls and indicators, let's take a look at the fuel tank structure and basic functions of the fuel system. A320 series aircraft have no fuel dumping capability. Also, fuel transfer from one wing to another is not possible in flight. Five main fuel tanks are provided: a center tank, two inner wing tanks, and two outer wing tanks. A total capacity of the main tanks is 41,285 pounds, based on a density of 6.551 pounds per U.S. gallon. There is a vent surge tank outboard of each outer wing tank to allow for fuel expansion. Overpressure protection is provided in the vent tanks, each wing tank, and between the center and the left inner wing tank. Let's look at the structure of the fuel supply system. Two electrically controlled transfer valves in each wing open automatically when the inner wing tank fuel level reaches approximately 1,650 pounds to allow the outer tanks to empty into the inner tanks. There are two fuel pumps in the center tank and two fuel pumps in each inner wing tank. The left inner wing tank pumps and the left center tank pump feed engine 1. The right inner wing tank pumps and the right center tank pump feed engine 2. Two electrically controlled engine low-pressure fuel valves can be used to cut off fuel flow to the engines. The valves can be controlled by the crew using the engine master switches or the engine fire push buttons. The fuel system is divided into the left and right side. The two sides may be connected using a crossfeed valve. It is normally in the closed position. It can be controlled by the crew using the crossfeed push button on the overhead fuel panel. The APU is also supplied by the fuel system. Fuel is provided to the APU from the left side of the crossfeed valve. A low-pressure fuel valve is provided to allow APU fuel cutoff. The valve is electrically controlled using APU master switch push button. You have now seen how the fuel pump supply fuel to the system. Now we will discuss gravity fuel feeding. If both pumps in an inner wing tank fail, a suction valve in the affected tank opens automatically to provide fuel to the respective engine. The inner wing tank suction valves are normally closed by the pressure generated by the pumps during normal operations. Suction valves are not installed in the center tank, therefore gravity fuel feeding from the center tank is not possible. The suction valves cannot be monitored nor directly controlled from the cockpit. The engine-driven IDG's oil system uses fuel for cooling. The fuel is provided by the high-pressure fuel line of the respective engine. After being used for oil cooling, the fuel is directed to the respective outer wing tank. If the outer wing tank is full, fuel overflows into the inner wing tank through a return spill valve. Let's briefly cover a fuel system computer. The fuel quantity indication system provides fuel-related information to ECAM and controls the automatic refueling process. The FQI computer has two channels. Channel 1 is primary. Channel 2 becomes active if Channel 1 fails. Sensors are provided to measure the fuel density level and temperature. This concludes the overview section. Now it's time for controls and indicators.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
Controls and indicators include the ECAM fuel page, the overhead fuel panel, and messages displayed on the EWD. We will start with the fuel panel page. Fuel page indications include fuel used indications. Fuel used since engine start automatically resets to 0 at next engine start on the ground. Fuel used by both engines is summed and displayed in pounds. The engine number is displayed in white when the engine is at or above idle and in amber when below idle. The fuel used indications are displayed in green when the first engine is started and remains displayed until electrical power is removed at the end of the flight. When the engines are started on the next flight, the values are automatically reset to 0. In this slide, we see some possible low pressure valve indications. Shown here are some possible crossfeed valve indications. Here are some APU low pressure fuel valve indications. Center fuel tank. Inner wing fuel tanks. Outer wing fuel tanks. Center tank pump indications include here are some possible wing tank fuel pump indications. Here are some possible transfer valve indications. Note, although not displayed on the fuel page, there are 2 transfer valves between each outer and inner wing tank. Fuel quantity indications. Here are some different possibilities for fuel quantity indications. Fuel quantities boxed in amber indicate that the fuel is unusable. Fuel temperature indications are not displayed if the respective tank is empty. They are normally displayed in green. During certain phases of flight, the fuel page is automatically displayed and the fuel temperature indication pulses green if the temperature exceeds certain limits. In some cases, an ECAM message may also be generated and the fuel temperature displayed in amber. Shown here are some possible fuel flow indications. Those are the indications displayed on the fuel page. We will now move on to the fuel system indications displayed on the EWD. We will look at the following EWD messages. Fuel on board indication. Outer tank fuel transferred message. Displayed in green if one transfer valve is opened in either wing. Remember, there are 2 transfer valves in each wing. They are between the outer and inner wing tanks. The valves open automatically when inner tank fuel reaches approximately 1,650 pounds and are latched open until the next refueling. A refueling message is displayed in green when the refueling control panel door is open. A center tank feeding message is displayed in green when a center tank pump is operating. Shown here are two possible fuel crossfeed messages. Now let's discuss the controls and indicators provided on the overhead fuel panel. The fuel panel is located near the center of the overhead panel. Shown here are some possible left and right tank fuel pump push buttons indications. Crossfeed push button indications, center tank mode select push button indications, center tank pump 1 and 2 push button indications. That concludes the controls and indicators section. In this section, you will operate and monitor the fuel system during a normal flight. We will begin with the pre-flight activities and continue to the post-flight shutdown of the system. Fuel system items checked during the exterior pre-flight are covered in the exterior pre-flight lesson. When you arrive at the aircraft, you notice that it is being refueled. While this is a common occurrence, the flight crew is typically not involved in the refueling process. If your involvement is required, detailed instructions, including the operation of the refueling panel, may be found in the appropriate aircraft manual. The refueling control panel is located on the fuselage below and forward of the right wing. The refuel coupling is located on the underside of the right wing outboard of the right engine. Although manual control of fuel distribution during refueling is possible, the process is normally done automatically. All that is required is that a desired total fuel quantity be set in the pre-selected window of the refueling panel. The fuel is automatically distributed to the appropriate tanks. Refueling may be accomplished with only one battery power available. It takes approximately 17 minutes to fill the wing and 20 minutes to fill all the tanks.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
Automatic refueling normally fills the outer wing tanks first. If the selected total fuel quantity exceeds the wing tank capacity, the center tank and the wing tanks are fueled simultaneously. The outer wing tanks are the first wing tanks to be filled. When they are full, fuel overflows into the inner wing tanks through spill valves. The refuel valves close automatically when the selected total fuel quantity is reached or a high level is sensed. Let's look at how the fuel is distributed after refueling is complete. These numbers are approximate and will vary based on fuel density. For fuel loads up to 27,004 pounds, all fuel is contained in the wing tanks. There should be no fuel or minimum fuel less than 300 pounds in the center tank when the wing tanks are full. Advance to see the aircraft fuel to 27,004 pounds. Any fuel in excess of 27,004 pounds is contained in the center tank. Advance to see the distribution of a full fuel load. Keep in mind that if the selected fuel load was in excess of 27,004 pounds, the wing tanks and the center tank would fill simultaneously. For this reason, a spurious ECAM message may be generated during the refueling process. We have continued the cockpit pre-flight and are now looking at the overhead fuel panel. All of the pumps are off. This is a normal indication at the beginning of the pre-flight. The refueling memo indicates that the refueling panel door is open. The refueling memo will be removed when the refueling panel door is closed. Advance to close the refueling panel. The door oxy page would normally be displayed. The fuel page is displayed for training purposes. The APU low pressure fuel valve is depicted in white, indicating that the valve is closed. Advance to simulate starting the APU. The green triangle indicates that the APU fuel valve is open and fuel is being provided to the APU. The APU uses fuel from the left inner tank with pressure supplied by a dedicated APU fuel pump that you can neither directly control nor monitor. During the pre-flight, you will need to verify the fuel load and distribution. This involves comparing the fuel on board with the dispatch release and ensuring there is sufficient fuel for the flight. It also involves verifying that the distribution of fuel is correct. Refer to your aircraft manuals for more information on fuel limitations. The only fuel-related item left to accomplish prior to engine start is to select all the fuel pumps on. As each tank pump push button is selected on, lights out, the associated fuel pump indication on the fuel page changes from cross-line amber to inline green, indicating delivery of fuel pressure. Advance to select all the fuel pumps on. With the Mode Select push button in the auto lights out position, center tank pump operation is entirely automatic. More on that shortly. Let's see how the fuel page changes during engine start. The indications and starting procedures are the same for both engines. The engine page would normally be displayed, but we will continue to display fuel page for training purposes. Before starting the engines, notice that the engine low pressure valves are cross-line amber, indicating they are closed. The fuel used quantities remain from the previous flight, and the engine identification numbers are amber because the engines are not running. Advance to start engine 1. The engine 1 low pressure fuel valve is open, and the engine 1 and total fuel used quantities have been reset. The engine number is now displayed in white, indicating that the engine is running. Advance to start engine 2. Now the engine 2 low pressure fuel valve is open and the engine 2 fuel used has reset. At this point, the center tank pumps are supplying fuel to the engines and the APU. Pressure reducing valves on the wing tank pumps allow the center tank pumps to pressurize the fuel manifold when all the pumps are running. This allows the fuel in the center tank to be used first. When the center tank is empty, the center tank pumps are automatically deactivated and the wing tank pumps provide fuel to the system. Now that the engines are running, the APU can be shut down. Advance to select the APU master switch off and shut down the APU. The APU is now shut down. The fuel page indicates that the APU fuel valve is closed. At this point, center tank fuel is not only being provided to engines, but also to the IDGs for oil cooling. After being used for IDG oil cooling, the fuel is delivered to the outer wing tanks. If the outer wing tank is full, the fuel is directed to the inner wing tank through a spill valve. If an inner wing tank reaches an overfill level, the respective center tank pump is automatically deactivated to allow fuel to be burned from the full wing tank. In this example, the left center tank pump has been deactivated. The pump is automatically reactivated when the inner wing tank fuel level is reduced. Both center tank pumps are now running. There are other conditions that cause the center tank pumps to deactivate automatically. Keep in mind that in order for the center tank pumps to operate automatically, the Mode Select push button must be in the auto position. In addition to the IDG cooling scenario we just discussed, if the Mode Select push button is in the auto position, the center tank pumps deactivate if the slats are extended for 5 minutes after a center tank low level is detected. One exception to this is that the center tanks run for 2 minutes after engine start, regardless of slat position. Advance to select flaps 1. With the slats in position 1 or greater, the center tank fuel pumps are automatically deactivated. This ensures that each wing tank provides fuel to its respective engine during takeoff and landing. That concludes the ground operations portion of our flight. We are now in flight. In-flight operation of the fuel system is automatic. Notice that after takeoff, the wing tanks are still providing fuel to the engines because the center tank pumps are deactivated with the slats extended. Advance to select flaps 0. The center tank pumps automatically activate when the slats are retracted. During the majority of the flight, other than fuel calculations, the fuel page indications you see here will remain essentially unchanged. The center tank continues to provide fuel until it is empty. The center tank pumps automatically deactivate 5 minutes after a low level is sensed. At that point, the wing tank pumps will provide fuel to the engines. Advance to reduce the center tank fuel quantity to 0.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
Here is a summary of the automatic center tank pump logic. Keep in mind that if there is fuel in the center tank, the 2-minute test of the center tank pumps will always occur after engine start, regardless of other conditions. For example, slat extension. An additional point to remember is that if either inner wing tank reaches the overfill level, only the respective center tank pump is deactivated. After the center tank is empty, fuel is fed from the inner wing tanks. The transfer valves between the inner and outer wing tanks open when the fuel level in the inner wing tanks reaches approximately 3,300 pounds. 2 fuel level sensors are installed in each inner wing tank. One sensor in each inner wing tank is effectively paired with a sensor in the other inner wing tank. Each pair is connected to 2 transfer valves, one in each wing. If either sensor in a pair detects a low fuel level, a transfer valve in each wing opens. This ensures that simultaneous transfer occurs. The remaining transfer valves open when either of the other sensors detect a low fuel level. Advance to see the transfer valves open. Note, the 1,650 pound value is based on level unaccelerated flight. During descent, acceleration, or deceleration, the transfer valves may open with more than 1,650 pounds in each inner wing tank. The outer tank fuel transferred message is displayed if any single transfer valve opens. With the transfer valve open, the outer tank fuel is allowed to flow into the inner tanks. At approximately a burn rate of 6,000 pounds per hour, there is approximately 1 hour of fuel remaining. This completes our discussion of the fuel system in flight. We have arrived at the gate. The engines are shut down. We have started the APU for you. It is time to select all the fuel pump push buttons off. Advance to select all the fuel pumps push buttons off. The crossfeed and mode select push buttons remain in their current position. Notice that the fuel use figures remain and the transfer valves are still open. They will remain latched open until the next refueling. That concludes the normal operations section. We are going to cover a few fuel system malfunctions and will end each abnormal with a review of the status page. The first abnormal we will look at is a failure of the center tank pumps. We are in cruise and all systems are operating normally. Notice that the center tank pumps are currently running. Advance to activate the malfunction. Center tank pump 1 has low pressure. The fault light in the center tank pump 1 push button is illuminated and the fuel page is automatically displayed. The amber box low indication means that the pump is on but not producing adequate pressure. Advance to perform the first ECAM step. The on light illuminates on the crossfeed push button indicating a command has been sent to open the crossfeed valve. Notice that the valve is indicated in transit on the fuel page. When the crossfeed valve is fully open, the open light in the crossfeed push button will illuminate. The valve will be displayed in line green and fuel crossfeed will be displayed on the EWD. Advance to see the crossfeed valve open. Opening the crossfeed valve allows the center tank to provide fuel to both engines. If the crossfeed valve is not opened, the left inner tank would provide fuel to engine 1 and an imbalance would occur. Advance to perform the next action step. The fault light in the center tank pump 1 push button has extinguished and the off light has illuminated. The pump now indicates off on the fuel page. Advance to clear the message and display the status page. The status page displays center tank pump 1 in the in-op system column. Now let's look at a failure of both center tank pumps. Advance to fail center tank pump 2. Center tank pump 2 has failed. The fuel center tank pump's low pressure message indicates that both center tank pumps have low pressure. The other indications are the same as the pump 1 failure with one exception. Notice the amber half box around the fuel on board indication on the EWD and the amber box around the center tank fuel quantity on the fuel page. Those indications mean that fuel is trapped. The center tank unusable step is reminding you that gravity fuel feeding from the center tank is not possible. Advance to perform the first action step. Both center tank pumps are now off. Advance to clear the message and display the status page. The status page also reminds you that the center tank fuel is no longer usable. Both center tank pumps are listed in the in-op system column. Before we leave this abnormal, let's review what we have covered. Loss of one center tank pump requires that the crossfeed valve be open to prevent a fuel imbalance. Loss of both center tank pumps result in the center tank fuel being unusable. Now we look at a wing tank pump failures. Once again, we are in cruise and all systems are operating normally. Advance to fail left wing tank pump 1. The master caution lights do not illuminate and the single chime does not sound. This is because the loss of a single wing tank fuel pump does not affect system operation. It is a redundant system. The fuel page is displayed and indicates that the fuel pump has low pressure. Advance to perform the only action step associated with this malfunction. The fault light in the left tank pump 1 push button has extinguished. The off light is illuminated and the fuel page indicates that the pump is off. Advance to clear the message and display the status page. Left tank pump 1 is listed in the in-op system column. Advance to fail left tank pump 2. The ECAM indicates that both left wing tanks pumps have failed. The ECAM procedure requires that the center tank pumps be operated in manual mode. This overrides the automatic logic and ensures that the center tank pumps continue to run. Advance to perform the first action step. The man light in the Mode Select push button is now illuminated. The center tank pumps are in manual mode. It is up to the crew to select the pumps off when the center tank is empty. Advance to perform the next action step. Both left wing tank pumps are now off. The ECAM message indicates that left wing tank fuel is only available using gravity feed. When the center tank is empty, you will have to select both center tank pumps off. When left wing tank fuel is required, merely close the crossfeed valve and engine 1 will be gravity fed. Specific gravity fuel feeding procedures can be found in the appropriate aircraft manuals. Advance to clear the message and display the status page. The status page reminds you about the gravity feeding issue and that the center tank pumps must be operated in manual mode. Both left wing tank pumps are now listed in the INOPS system column. Before we leave this abnormal, let's review what we have covered. Loss of a single wing tank pump is not critical. Losing both pumps in one wing tank might require gravity fuel feeding procedures. Now let's move on to a fuel quantity indication abnormal. Amber dashes displayed across the last digits of the fuel on board indication on the EWD indicates that the fuel quantity indicator computer is operating in a degraded mode. Advance to display the fuel page. The left inner tank is affected. Only one abnormal to go. Let's look at it now. Both left tank transfer valves have failed to open. Notice that at least one right tank valve has opened. The fuel in the left outer wing tank is unusable. That concludes the abnormal operation section. This section of the fuel lesson will cover the differences between the A319 and A321 fuel systems. The fuel system has the most significant differences between the A319 and A321. We will cover the differences in the fuel tank structure, distribution, fuel use, controls and indicators, and a few abnormals. The A321 has fuel tanks located in the center fuselage area and the wings. Each wing tank consists of one fuel tank and its associated vent tank. The total usable fuel quantity is approximately 41,000 pounds at standard density.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
Fuel is always fed to the engines from the wing tanks. Center tank fuel is transferred to the wing tanks by two mode flow jet pumps located in the center tank. The mode flow jet pumps are driven by fuel flow from the main tank pumps. Fuel transfer from the center tank to the wing tanks is controlled by transfer valves. When the center tank transfer valves are open, fuel from the wing tank pumps flows through the jet pumps, creating suction. This suction draws fuel from the center tank and transfers it to its respective wing tank. A fuel level sensing control unit provides automatic control of the transfer valves. When a wing tank is full, the FLSCU automatically closes the respective transfer valve. The FLSCU reopens the transfer valve when the fuel level in the respective wing tank is reduced approximately 550 pounds. Transfer valve operation continues in this manner until 5 minutes after the center tank is empty, then both valves close. Once again, on A321s, fuel is never fed from the center tank directly into the engines or fuel manifold. Some A321s have additional center tanks. Up to 2 ACTs can be installed. Each ACT holds approximately 5,178 pounds. This allows for an approximate total fuel load of 51,370 pounds on those aircraft. A321 with ACTs use fuel in the following order: from ACT-2 to the center tank until ACT-2 is empty, from ACT-1 to the center tank until ACT-1 is empty, then from the center tank to the wing tanks until the center tank is empty. Automatic control of the fuel transfer from the ACTs to the center tank occurs in flight after slat retraction. The ACT uses cabin air pressure to transfer fuel. When ACT fuel transfer is required, the fuel level sensing control unit opens the appropriate ACT inlet valve and the ACT transfer valve. The ACT transfer valve closes if a high fuel level is sensed in the center tank during ACT fuel transfer. The valve reopens if a center tank high level is not sensed for 10 minutes. The ACT transfer pump will pump ACT fuel into the center tank if cabin air fails to pressurize the system and ACT fuel transfer is required. The fuel panel and the fuel page you see here represent the A321s without ACTs. The fuel page only depicts a center tank and one tank in each wing. Remember that fuel is transferred from the center tank to the wing tanks via 2 jet pumps and transfer valves. Fuel is always fed to the engines from the wing tanks, not from the center tank. The path of the fuel transfer is depicted on the fuel panel and the fuel page. Notice that there are no center tank pump push buttons. Instead, are center tank transfer push buttons. We will cover those shortly. The A321 center tank mode select push button is normally left in the auto position. In the auto position, fuel tank transfer from the center tank to the wing tanks is automatic. The crew can control the transfer of fuel manually by selecting the push button to man. However, and this is very important, if you operate the valves in the manual mode, you are responsible for closing the valves when the wing tanks are full or when the center tank is empty. The center tank left and right transfer push buttons can be used to manually control the respective transfer valve. They are normally left in the on, lights out position. It is important that you understand that these push buttons are used to control valves, not pumps like on the A319. On this A321 fuel page, you may at first glance think these center tank indications represent pumps. You would be mistaken. These indications actually represent the center tank fuel transfer valves. Remember, when the valves open, wing tank pump fuel flow allows the jet pumps to create suction in the center tank, transferring fuel to the respective wing tank. On A321s with LCD screens, the fuel page looks slightly different, but the center tank transfer valve indications represent the valve position in the same way. On the LCD fuel page, there are a couple of additional fuel transfer indications. On the EWD, the fuel on board below 3T message is displayed when the fuel quantity in either wing is below approximately 3,300 pounds. Now we will look at some A321 specific fuel system abnormals. The center tank left transfer valve has failed to close. On the fuel page, the center tank left transfer valve is displayed cross-line amber, indicating that the valve is not fully closed. The first action step is an attempt to gain manual control of the transfer valves. Note, the fault in the center tank transfer push button only illuminate if the respective wing tank overflows. Advance to select the Mode Select push button to man. The two center tank transfer valves are now manually controlled using the left and right center tank transfer push buttons. In the manual mode, with the left and right center tank transfer push buttons selected on, both center tank transfer valves should open. Our attempt at gaining manual control over the inoperative transfer valve was unsuccessful. The right wing tank pumps must now be used to feed both engines. Using only the right wing pumps to provide fuel ensures that the center tank fuel is used and that the fuel remains balanced. Advance to perform the next action step. The crossfeed valve is now open. This is indicated by the green open light in the crossfeed push button and the inline green crossfeed valve indication on the fuel page. Advance to select left tank pump 1 push button off. Left tank pump 1 is now displayed crossline amber, indicating that the pump has been selected off. Another indication is that the white off light in the left tank pump 1 push button is illuminated. Advance to select left tank pump 2 push button off. The left wing tank pumps are now off. The ECAM steps are complete. Advance to clear the message and display the status page. The left center tank pumps and the center tank left transfer valve are inoperative. Center tank fuel transfer is being done manually. Now let's look what happens in this situation when the center tank is empty. This is what the fuel page and the fuel panel look like at the end of our previous abnormal. Eventually, we will burn all the fuel from the center tank. Advance to reduce the center tank fuel quantity to 0. The left transfer valve fault message is displayed again. The steps have changed because the center tank is empty. The first step is to select left tank pump 1 push button back on. Advance to perform the first ECAM step. The left wing tank pump 1 is now on. Advance to select left tank pump 2 push button on. Both left wing tank pumps are now on and feeding engine 1. Advance to close the crossfeed valve. The crossfeed valve is now closed. Advance to clear the message and display the status page. The status page displays a reminder that center tank feeding is under manual control and that the center tank left transfer valve is inoperative. We have one more abnormal indication to cover before we move on. If a wing tank overflows, the respective fuel quantity is displayed in amber and the fault light in the respective center tank transfer push button illuminates. A wing tank overflow is the only condition that causes a fault light to illuminate and a center tank transfer push button. That concludes our discussion of A321 fuel system abnormals. Now we will look at the controls and indicators on A321s with additional center tanks. We have covered A321 center tank structure and operation, including how center tank fuel is transferred to the wing tanks. Remember, the center tank functions that we have just covered apply to all A321s. We will now look at the additional controls and indicators on A321s with ACTs. The LCD and CRT style fuel pages on these aircraft are almost identical in their depiction of ACTs. Both fuel pages have indications that represent the ACTs and the fuel quantity in each tank. In addition, Both fuel pages have an ACT to center tank fuel transfer indication. The overhead fuel panel on A321s with ACTs has one additional push button labeled ACT. The ACT push button is normally left in the auto, lights out position. In the auto position, fuel transfer from the ACTs to the center tank is automatic. Pushing the push button initiates a manual transfer from the ACTs to the center tank. If this is done, it is the crew's responsibility to return the ACT push button to the auto position when the center tank is full, to prevent overflow or when the ACTs are empty.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.